Okay, so we are moving on to Unit 7 solution. And yes, I know that the last unit that we did was Unit 5, moles and stoi. So you're asking what's happened to Unit 6? Well, we're going to do Unit 6 after Unit 7. I've kind of changed the order of things. We just talked about moles and stoichiometry with solids, so I felt it was best to move into solutions, and then we'll move into physical behavior. So this is lesson 1, and we are going to actually review a lot of vocabulary terms. We're going to talk about the difference between heterogeneous and homogeneous mixtures, which we've already talked about before. We're going to revisit that, and we're going to learn about the different types of heterogeneous mixtures, including colloids and suspensions, and the different types of homogeneous mixtures, alloys and solutions. Okay, so a mixture is, remember, a combination of two or more pure substances. These can be elements and or compounds that can be separated by physical means. So remember, a mixture can be separated by physical means. It's like taking sand and salt and mixing them up in a bowl, and then I ask you to separate them. Well, how would you do that? You'd mix some water with it, dissolve all the salt, then filter the solution with the sand. The salt water will go all the way through, the sand will get trapped in the filter paper, and then you could evaporate the water to get rid of it and be left with just the salt. So a mixture, and that's with separation all by physical means. And mixtures can be either heterogeneous, which you've already learned, which is a mixture of two or more pure substances in different physical states. And the composition varies within the mixture. It is not uniform throughout. So that could be like Italian salad dressing. It could be like chocolate chip cookie dough. You're not guaranteed the same amount of chips in each spoon of dough. Classified under heterogeneous mixture, we have what's called a suspension, and that's something that clearly separates. And here they give you an example of water, clay, and sand. So it eventually separates upon standing. The solid does not visibly dissolve in the liquid or break down. We can separate by what's called filtration. We're using a funnel and filter paper. And this has a relatively large particle size. So as I said earlier, this could be Italian salad dressing, when you have the oil, vinegar, spices. It could be sand in water, and it could be chocolate chip. Chip cookie dough. So that's heterogeneous. Now let's look at a colloid, which is also a heterogeneous mixture that does not clearly separate. So we've got two types of heterogeneous mixtures. We've got suspensions, which will separate, and we have colloids, which won't separate. They tend to be cloudy in nature, They appear homogeneous, but they're really not. They do not settle naturally on their own through time. They can be separated by a centrifuge. And that is a machine. We have one of those in the back of the room where you put the colloid in a test tube and you put it in this machine and it spins it really fast, and then the heavier particles are forced to the bottom and the lighter ones on top. And this works great for medium to small particle size. Properties in between a suspension and a solution. So some examples here would be blood and milk. And if you've ever gone and had your blood taken, they put it in a test tube, and then when they send it to the lab, they actually centrifuge it, and they use the parts that they need and test them. Let's move on to homogeneous mixtures, solutions, mixture of two or more pure substances in the same physical state. We know that they are uniform throughout. And again, this should be a review. We've already learned this. Looks like clear, colored, or colorless water. So this looks like colored water, or it may look clear. This has basically a small particle size and may exist in any phase, but the liquid phase is the most common. So a good example here would be Kool-Aid or salt water, when the salt is dissolved in the water, or club soda, which is simply CO2 and water mixed. And then also under a homogeneous mixture we have an alloy, a solution where at least one of the materials is a metal, although most times there are two or more metals. So here you have zinc mixed with copper, which makes brass, which is called a substitutional alloy. I'm not going to test you on substitutional alloy, but what it really means is that some of the coppers are the brown ones, not the gray ones. The zinc is the gray. But in a substitutional alloy, you would take out, the majority of this is copper, you take out a couple of coppers and you'd put zinc in its place. And then here we have carbon and iron in an alloy, which makes steel. And this is called an interstitial alloy, and that's because interstitial means it goes in between the spaces. So the carbon atoms are put, because they're smaller than the iron, they fit in between the spaces of the carbon atoms. So metals arrange in an alternating pattern with a sea of mobile valence electrons, gluing them together. Some other examples, well, we have a zinc and copper is your brass, and then your iron and your copper is your steel. But in this unit we are going to focus on solutions only. But I wanted you to understand that we have different types of heterogeneous and homogeneous mixtures. So what are some characteristics of solutions? Well, we know that they're homogeneous, meaning that they are the same throughout. They are clear as opposed to cloudy and do not disperse light. So there is no Tyndall effect. They can have color or be colorless. They do not settle upon standing. And they cannot be separated by filtration. So what is the Tyndall effect? The Tyndall effect is not seen in solutions, as I said. It is seen when a mixture makes a beam of visible light. So if I pass a laser through a suspected material and I can see the laser light through the liquid, then I know I do not have a solution. If I can't see the beam of light, then I do have a solution. And I'm actually going to demonstrate that in class. So we'll do this in class. Solutions always assume the phase of the solvent. Well, remember, you have the solute, what's being dissolved, and then you have the solvent, what's doing the dissolving. So if I have salt water, the salt would be the solute, the water would be the solvent. So if my phase of the solute is solid and the phase of my solvent is solid, so I've got two, I'm putting one solid into another solid, then that would be a metallic alloy, because those were all solids. If my solute is a solid and my solvent is a liquid, then this could be, say, table salt and water. Which we call salt water. If I have two liquids, I could have one liquid going into another liquid. So this might be alcohol and water. Or if I put CO2 and water, then I get club soda. A gas solute and a liquid solvent. So I'm putting a gas into a liquid. Oh, I put this in the wrong spot. This one goes down here, sorry. One in each one. This is CO2 and water, so club soda. And then a gas, a good one would be just air. Okay, so as I said, the solute and the solvent, the substance or substances that are dissolved in a solution. The salt in salt water. The solute is usually a solid and is in the lesser quantity of the two. Because it's the solid part, it's usually smaller. The solvent is the substance that is dissolving the solute. So the water in salt water. it is usually a liquid, and this is the greater quantity of the two. So here you have your solute plus the solvent, and you get a solution. And that's it for tonight's lesson. You should be looking for a literacy assignment on different types of colloids, suspensions, etc.